All right, so in today's lecture, we'll continue talking about policies. In this case, we're going to shift gears a bit and we're going to talk about technical policies. The two policies we'll talk about, they stem from web browsers. Web browsers were something, so as far as I recall, the internet was created maybe in the 1970s. The early days of the internet focused on protocols like email. There wasn't really this notion of websites, and you would go and browse the web and go to different people's websites. As a result, there also weren't tools or software programs for allowing you to browse the web until about the 1990s. So that's when web browsers came out. It's when this notion of the World Wide Web came out. There was also some more like kind of walled garden approaches where you would subscribe, to an internet service provider, and then you could access websites that were hosted within that. But in terms of the open, internet, it didn't really come along until the 90s. The first major browser to break through to the mainstream was Netscape Navigator. It came in 1994. Microsoft introduced Internet Explorer, put it into all the copies of Windows that were being sold, and that came in 95. Now today we have things like Chrome, Edge is Internet Explorer, Safari from Apple, Firefox, Opera, and so there's other browsers as well. So going back to Netscape, what Netscape did is very early on, so in the first versions of Netscape, they had to work out a lot of, they made a lot of decisions about how websites should behave and how browsers should behave. And, they worked out different policies, which is the focus of the lecture. And so they worked out different policies for how the browser should handle certain types of circumstances. And no one had really thought these things through before, because there wasn't really a lot of browsers before, and the internet was just like in the very, very early days. Once they fixed these policies, then when new browsers came along, they would just sort of copy them. And so there have definitely been tweaks along the way, but for a large part, the decisions that Netscape made in 94, 95 still shape, the way that browsers work today to a large extent. So what we're going to do is we're going to look at two policies. Today, we're going to look at how browsers handle what are called cookies, and I'll explain what a cookie is as we go through it. And then next class, we'll talk about a different policy called the same origin policy, and it governs how a browser will handle active web content. So scripting in particular is the most important today, so like JavaScript and things like that. Okay, so we've seen this slide before when we talked about HTTPS, but we'll go over it again. So the content, when you download a website, let's say you go and you visit a website, you're getting a bunch of information from the web server. So your browser is receiving a bunch of information from it. And the first thing the browser is going to do is it's going to split what it's going to show to you, like what is part of the content of the website itself, and what is just information for the browser to know about the website itself that won't necessarily get displayed to the user. If you want to use an analogy of an envelope, there's a bunch of stuff that's inside the envelope, so that's like the content of the website, and then there's stuff that's written on the outside of the envelope. So cookies, which we'll talk about today, cookies are on the outside of the envelope. So they're not something that's displayed to the user. It's not part of the content of the website itself. It's something that's just getting sort of sent along with the website. And so it actually is added both when you request a website and also when you receive the website back. There's other things like, browsers will talk about, like what version of which browser it is. Like this is Safari, it's this version, maybe it's running on this operating system, this is the screen resolution, Here are some fonts that I have installed, or the website might ask for the fonts that are installed and things like that. So there's a bunch of other stuff that goes back and forth. That's just part of the communication between the browser and the website. Again, if we go back earlier in the course, we talked about Tor, and we talked about de-anonymizing people who are visiting your website if you're a web server. And you automatically know their IP address, but with things like Tor, VPNs or proxies, it's going to hide that information. Another way to track users is to try and figure out if their configuration looks like the configuration of any of your other users, and if it's somehow unique, like it has certain fonts that like that exact combination. You don't have any other user with that exact combination that's maybe running that version of, say, Safari, from a computer as opposed to a phone, that type of thing. So that's other stuff that gets passed back and forth in this meta content. Okay, then you have the content itself. So this is the resources on the website. So usually the base piece of content would be an HTML file that's going to define the website. But the HTML file, either inside of it or through links, it's going to pull in other resources. So it could be other HTML, it could be JavaScript, it could be some sort of scripting file, it could be video, it could be audio, it could be pictures. So all of these things come down. And then we also like to distinguish between passive and active content. So passive content is not code, it's just something that's going to get displayed. So the HTML itself is passive. The images, audio, video, they're all considered passive content. And then active content is things that is running. It's code that's being run. So JavaScript is the big one. XML HTTP requests is a little different. It's sort of it's the way that JavaScript requests that a website come down. So once JavaScript's running, it can also load resources itself. And the way it loads resources is through this protocol. Next class, when we talk about browser policies concerning scripting, we'll see all of these things again. CSS files is another one. It's a style file. So normally you would use it to say, you might install it, like say you have a website and you have 100 different subpages, but you want them to all look the same, like have the same menu options and have the same border and background and color scheme and fonts and things like that. So that's where you would put it in the CSS file. CSS files should arguably be passive content because it's not code. It's just a specification or a markup of what you want the layout to look like. The problem is that the CSS sort of format, it kind of slipped over the years, and developers wanted more and more powerful features in CSS, so they could do more just with the CSS file. And at a certain point, it kind of crossed the threshold where now it's dangerous. There's potentially attacks that could be conducted using these files, and so now we consider it active content, even though most CSS files themselves would not involve anything that looks like active content. Okay, what are the security goals in terms of a browser itself? So if we go back to Stride, what the browser is doing is it's essentially trying to provide two properties. So the first property is what you see is what was sent. So I'm looking at a website, it was given to me by google.com, and bit for bit what I'm looking at on my browser was bit for bit what the server sent and wanted me to see. Okay, so there was no tampering that sort of changed the content of the website or that type of thing. Okay, the other thing we care about is privacy. So what we exchange with one particular website or domain name shouldn't be seen by other people. Okay, so it could be other people that are on the wire that are listening to our content. So that would be like HTTPS that would prevent that. But you can also start thinking about, well, what happens if, let's say you load a website and, you're visiting one particular website, but there's content being loaded from a bunch of different websites. And it's all getting weaved together on the same page, right? what about those other websites? Do they know what you're doing on the primary website that you're visiting? Can they sort of trace you or track you? If you type information into that website, do they all get to see that, or is it just the primary website? So like, how do you isolate content when it gets weaved together from multiple sources? So things like that. So that's sort of privacy within a particular website that you're looking at. And then you can also think about privacy from the perspective of, let's say I visit the website today, I come back tomorrow, I didn't log in, maybe I changed my IP address, maybe I'm using Tor or something like that. Does the website know I'm the same person? It might not know who I am, but does it know I'm the same person or not? Okay, and so that particular privacy or information disclosure property is more relevant to what we'll talk about today. Okay, now let's consider just an example to warm up to the idea of cookies. So I go to my email client, say I use webmail, I use Gmail. So I go to Gmail, it asks me to log in, that's fine. I put my username, I put my password in, I log in, and it shows me my inbox. Okay, so I have 20 messages sitting there, and now I want to read the first message. Okay, so I click on the first message. Now we all know the answer to this question, but think about it for a second. Do I have to log in and give my password again to click on that first message and see that first message, right? Gmail knew who I was. It showed me my inbox because I just put my password in, right? Now I'm clicking on the first message, so don't I need to send my password again so that Gmail knows I'm the same person, or I'm allowed to look at that message? Okay, so we all know that, you just click on it and you don't have to log in again. Okay, but it's worth thinking about how, why? How does Gmail know that I'm the same person? Because technically this is a second request. I did the first request, which was give me my inbox. I go away. Maybe I go away for a while. Maybe I load my inbox. Maybe I'm like taking public transit and I load my inbox, and then I switch from cell tower A to cell tower B. Maybe during that switch, I get a new IP address. Maybe I'm on Wi-Fi, I'm just leaving my house, and I just, I cross the boundary where I switch off of Wi-Fi because my phone is connected to my house, and now it's connected to the satellite network, right? My IP address changes, my ISP changes, like everything about my internet connection just changed. But yet I don't have to log in again, right? So why is that? How does the website know that I'm the same person? It can't be based on IP address. You might think MAC address is another kind of unique address that computers and devices have, but MAC addresses can be spoofed. You can set it to anything you want. If you're interacting with me, I might know what your MAC address is, and then I could spoof you. Like, it would be very trivial to try and take over your identity if it was all based on MACs. So it has nothing to do with that. So why is it that a website knows that I'm the same person that's coming back? So think about it for a second. Okay, so the answer to this is going to be cookies. So what is a cookie? So first and foremost, what it is at a data level is it's basically just a number, or it's a piece of data, and usually there's a name for it as well. So a cookie will have a name, and then there'll be the value that it stores. Okay, so the name might be like a user identity or UID, and then the value for the UID would be set to whatever, probably hopefully a long, complicated looking string. And by number, I don't mean it has to be an integer. It's just data. So it could be a string. It could be an integer. For example, let's say you might have language would be the name of the cookie, and then English or French or something like that would be the value that's associated with it. Where does a cookie come from? How do you get one? So cookies are created by the website that you go and visit. So if you get a brand new computer, you turn it on, never been on the internet, you have no cookies. You have 0 cookies. And when you go to a website for the first time, what the website will do is you'll say, hi, I want index.html. And the website will say, okay, no problem. Here's index.html. But by the way, I'd like you to set... I saw when you asked for it that there weren't any cookies created yet. We'll get to that maybe in a second. But anyways, it will say, I want to set a bunch of cookies. And so it's an instruction to your browser. So that instruction comes into your browser. Your browser sees that this website wants to set a bunch of cookies. Assuming that your browser settings permit it to, then your browser will create those cookies. And and so they're marked in a set cookie header. And then what the browser will do is it's going to store that cookie value. And it's also going to remember the website that you were visiting when you got that cookie. Okay, and based on that information, it's going to do something with that in subsequently. And there's some rules and things like that, like little details that we have to go through. But in general, what it's going to try and do is every time you go back to the same website, it's going to send that cookie back. Okay, so future requests that you make to that same website, and we'll talk about what it means to be the same website in a lot of detail. The browser's going to, first it's going to check really quickly, like, do I have a cookie that's stored for that particular website? And then if it finds one, then it's going to put it into the header of the request itself. Okay, so every time you go to the website, you're sending the cookies back to the website. All right, so how does this solve the sort of Google Gmail kind of problem that we had? And so the answer is it solves it by when I log into Gmail, it sets a cookie, and then it will set a cookie that is kind of like a password. Like it will choose a long random number, and it will say, okay, this is your unique identifier. And in the back end, it's going to associate it with my particular account. And then when I come back, every time I come back, I'm going to send that same cookie value. And so it's going to keep seeing that same cookie value. And every time it sees that cookie value, it's going to know that I'm me. And then it doesn't have to ask me for my password anymore. Okay. Well, again, we'll talk about details here in a second. Okay. Now, how does the browser decide whether or not to include that cookie? That's what we need a policy for. So that's the whole purpose of this class is let's talk about what that policy is. Okay. So do I always send every cookie to every website? Do I try to only send it to the websites that set it? What does it mean exactly? Maybe they're related websites, but they're not exactly the same website. Like what exactly is the policy about when I send this cookie back? Okay, so this is just the same thing in sort of pictorial form. So here we have Alice, and say she asks Gmail for her inbox, and Gmail says, I don't know who you are, why don't you log in? So that's a request. So the give me the login page is a request, or the give me my inbox as I'm logging in is a request. What the backend database has, we've seen this before. Well, we've seen the first two columns before. Is we have Alice and we have maybe a hash, maybe a salted hash of Alice's password. And then now what we're going to do is we're going to introduce a new value, which we're going to call as a user identity or session ID. So SID stands for session ID. And again, it's sort of a password-like kind of object. So it's just a sort of random string. And what the server will do is it will associate the cookies it's handed out, the session IDs that it's handed out with the particular users themselves. Session IDs should be unpredictable or random. If I can guess what your session ID is, then I can log in as you. Okay, so I'll go back to the website, but I'll use your session ID. And then because the website is just it's trying to figure out if I'm the same user coming back, yes or no. And it's based solely on this value. I'm not presenting my password. I'm not logging in again. So my ability to cough up this particular number governs whether I get into the website or not. Okay, so in other words, so it needs to be unpredictable and random. It also needs to be encrypted. So we don't want anyone that's in the middle to be able to read it. Okay, so even though it's in the header, it's still under HTTPS. Okay, so HTTPS will encrypt headers as well as the body for any information that's going back and forth. Header, it's a little bit of a confusing discussion because the SSL packets or TLS packets themselves have headers. So the header of a TLS packet is not encrypted. But this goes to networking. You don't really have to know these details at all, but just for your interests, networking kind of works like a stack. So you sort of have packets that are inside of packets that are inside of packets. And so all this cookie stuff is happening sort of at the HTTP level. HTTP as opposed to, I don't know, I'm sort of not explaining it well, but anyway, so it happens in terms of like exchanging HTML information. You have the body of the HTTP, you have the headers themselves. All of that gets put into what's called a TLS record. And the TLS record will include everything, but then the TLS record itself will have a header, and that header would not be encrypted. That header would include things like the IP address. So we noted that before, if you go to a website and you're going over HTTPS, someone in the middle, if they look at the packet, they know who you are as the sending IP, and they know the domain name that you're visiting because they know the IP address of where it's going. And they can turn that into a domain name by doing a reverse DNS lookup. So anyways, long story short, with or without the networking details, OSI model stack stuff, the cookie is part of the encrypted payload of it. So you don't have to worry about cookies being on the outside of the TLS envelope. They're going to be on the inside of the TLS envelope. Now, if you're accessing a website, okay, and the website is not going over TLS, okay, then you could pull that cookie value out if you were in the middle. And if you pull that cookie value out, then what you can do is you can create a connection to that website, use the value that you pulled out, and you now are that person as far as the website is concerned. It's more or less as good as having someone's password. Okay, so if you're able to lift someone's session ID, put it in your own packet, then when you visit the website, you're just automatically logged in as that person itself. So you've probably heard the term session hijacking. And so session hijacking is exactly this attack. It's getting someone's session ID, lifting it out of their packet, putting it in your own packet, and now when you visit the website, it's as if you are that user and you're already logged in. So session hijacking is it's more or less as powerful as stealing someone's password. Sometimes, and you'll notice for websites, what they'll do is if there's some like deep administrative settings, like say you want to actually change your password or you want to delete the account or things like that, what the website will do, even though you're logged in, is they'll make you log in a second time. They'll say, okay, you know, in order to do that, you need to supply your username and password. And so the reason they're doing that is because they recognize that it's easier to steal someone's session than it is to steal their password. And so what that does is it prevents, if you get session hijacked, then the person, the attacker, you know, they can do a lot of damage, I'm sure, but they can't do complete damage. There are a few administrative things that they will not be able to do without supplying a website. So again, that's up to the website themselves. They decide how that looks. That's a policy, you know, for the website themselves in terms of which are the administrative functions we're going to put behind requiring a second authentication or a password itself. But anyways, if you ever, you know, go to change your password and ask you to log in again, that type of thing, then you'll know that that's the reason why. The other thing I want to do is tell you a quick story. So this is about something called Firesheep. Firesheep this is an old story. I apologize, a lot of my stories are old. This goes back to 2010. But what happened is that back in 2010, lots and lots of websites did not run over HTTPS. The way they worked is you would go to the website, they would ask you to log in. They knew that, passwords were sensitive. You don't want passwords in clear text going across the network. And so what they would do is they would throw you onto an HTTPS connection. They would take your password from you. And then once you've logged in, they would set a session ID and have the session ID, stored. And then they would throw you back onto HTTP. And the rationale there was that HTTPS is expensive because you're encrypting a lot of data. And so if, maybe it's like a website like Facebook is a classic example from that era. So Facebook, there's a lot of images and things like that. And so they don't want their servers to have to encrypt every image every time it sends it to a user. And so the thinking was that HTTPS was prohibitively expensive, so let's use it just to get the sensitive information, which is the password, and then get off of it as quickly as possible. Now today, encryption is built into the hardware level, like the chip level of most web servers and things like that, and so the cost of doing HTTPS is negligible over doing HTTP. So there's no performance difference at all. But anyways, that's sort of beside the point. Now people also understood that in theory, if there was a man in the middle, you could pull the session ID out after you've switched back to HTTP. And with that session ID, you could log in as the user that you stole their session from. So in other words, people understood that session hijacking was possible. In fact, it was easy, but the hard part was getting in the middle, right? So it's very, very difficult to get into the middle normally of most connections. So it was sort of marked up as a hypothetical attack, but one that no websites were really protecting themselves against. Then what happened is someone said, let's take this attack and make it super easy as possible. So what they did is they developed an extension that you could install in your browser. So you didn't even have to install any new software. You just got an extension for your browser. It worked in Firefox, and it was called Firesheep. And what it would do is if you were on a Wi-Fi network, and it was public and it had to be configured in a certain way, but in a very common configuration, what it would do is it would kind of poison the routing tables in the Wi-Fi network, and it would get it so that everybody on the Wi-Fi network that was connected alongside of you, all their traffic was going through you. So you were the man in the middle for that particular Wi-Fi router. And normally, if HTTPS is enabled everywhere, it's not a great thing that someone can connect to your Wi-Fi and become a man in the middle for your Wi-Fi network. But at the same time, it shouldn't really matter that much if we're using HTTPS. But back in this world, we weren't using HTTPS. So you couldn't steal people's passwords, but what you could do is you could steal their cookies. Now, a second sort of challenge is, okay, you see some network packets go by. Do you know how to reach in, figure out which cookies are which? And then, you're going to reconnect to the same website. And when you connect to the same website, you're going to send that hijacked cookie. There's a technical sort of hurdle or challenge there. And so what Firesheep did is it also completely automated that process as well. So the user experience of using Firesheep was you go to, say, Starbucks or somewhere that has a public, say, a library, Concordia Library. You log on the Wi-Fi. You open Firesheep. It just opens a separate window. And what happens is that people's social media profiles, it supported Facebook, Twitter, and other ones that were popular again in 2010, they would just show up in this side window, with their username and their picture. And then if you want to be them, you just double click. And then boom, now you're looking at this person's Facebook account, or you're looking at this person's Twitter account. So it really, really, it took an attack that was sort of difficult to do and made it so slick and easy for users to do that, it just became this sensation in terms of the media, and everyone was freaking out about it. And, people were doing this. And so then what happened is that all the social media sites, they switched. So here you can see, this is for Facebook. You can see what it looks like. So you have this extension. You can see there's a bunch of accounts, Google, Flickr, Twitter, Facebook. And I just like double click on it and then boom, I'm into that person's account. So anyways, sometimes, there's a few events that like really caused the world to change in terms of security. And Firesheep was one of those events. So it was one of those events that made lots of people turn HTTPS on, not just for collecting passwords, but like the entire duration of when you're logged into a website, you're using HTTPS for the entire duration itself. Okay. So let's go back to our picture here. So what Alice did is she sent a request. What the mail server did is it sent back, it said, okay, I want you to set this cookie. This is the value of the cookie. And although I said that this is Alice, that's for your information, but the web server here doesn't know that it's Alice. All it knows is that some user came and they asked, to log in or see their email or whatever. At this point, we're going to assume they haven't put their password in. And so what it does is it will create a sort of entry and it will say, okay, I have a user. I don't know who it is. So I don't know their password because I don't know who the user is, but I'm assigning them this session ID. And then if that user ever comes back, the idea is that I'll know that they're the same user. I won't know who they are, but I'll know that at least they're the same user that's coming back to the website. Okay, and so when they send this set cookie to Alice, what Alice's browser does is it says, okay, this is a message to me. And so the browser has a file called the cookie jar, and the cookie jar has all of the cookies that it's set for every website itself. So what it will do is it will put this new cookie into the cookie jar. So the value of the cookie is this. The name of the cookie is this. Both of these things are decided by the website. So the website mail server, in this case, it can decide, it can name it whatever it wants and it can put whatever value it wants in it. And then what Alice's browser will remember is when I got this cookie, the website I was browsing was mail.google.com. Okay, so that was the website that I was browsing at the time that I got this particular cookie. Now there's a little bit more inside of the cookie and we're going to get there in a few slides. There's a bit more information, but anyways, just for now, this is a simple view of it. Then what Alice will do is, let's say she's going back to mail.google.com, like now she's ready to say log in and send her username and password. She creates her request, but the browser will intercept it. It will say, okay, I see you're about to send a request to mail.google.com. Let me quickly go over to my cookie jar and just see whether or not I have any cookies that belong to mail.google.com. It sees that, oh yeah, I do have this cookie. And so what it does is it puts it at the start of the request. Okay, so now the cookie goes back to mail.google.com. Now, you might think, oh, mail.google.com would be like, okay, that makes sense because I just sent Alice this message and now I'm getting a response back. But remember, Google has 1 million people that are connected at the same time. People, they change their IP address, their devices change it and things like that. And so Google has no idea, like it looks on this slide like it knows when the second request comes back, it knows that it was the person that it just responded to. But the truth is Google doesn't know that at all. Okay, it doesn't want to try and keep track of that information. Okay, so the reason that it knows that this is the same person that it sent the response back to is because of this cookie value, because of this session ID. That's the only way that it knows that it's the same person. Okay, so it receives this request. It's almost like I got this request from someone, I have no idea who it is. Let me go check real quick. So it will go back to its table and it will say, oh yeah, okay, I see this cookie before. It's in my table. I recognize it. I don't know who it belongs to. Okay. Now this table, I should mention a few things about it. This is up to Google themselves. So the way they implement the table is how they want to implement the table. There's nothing about the browser or Alice. Alice has no say. No one can see what this table looks like for any web server itself. Maybe a cookie value gets sent and it's not in the table, right? then it's up. What happens to the mail server, how it handles it is up to the mail server. So the mail server can decide whatever it wants. First off, it would know that it has never seen this user before. It might create a new entry using that cookie, or it might say, I don't know who you are, and it might try to set a new cookie that it chose. Notice that Alice could send any cookie here if she wanted to. So, or she could change it. Her cookie jar is located on her computer. She could go in and change the value of this cookie if she wanted to. And again, that's how you do session hijacking. If I have your cookie value, I go into my cookie jar, I change my value to your value, and then I send it. But I could also just like make up random values and things like that. So the mail server, we can't say how they're going to handle, cookies that don't match and things like that. Okay, then later, let's say that Alice is going to log in. So she's going to send her username and her password. Again, because she's going to mail.google.com, her cookie is going to go along for the ride. So it's always going to go to every request to this website. Now what the mail server will do is it will say, okay, looking at the cookie value, I see the cookie value. It's in my database. And assuming that the username and password is correct, then now I know this is Alice. Okay, before I didn't know who it was. Now I know it's Alice. It's the same person here. And the same person might have multiple session IDs. Usually, again, this is a good point to emphasize again. The cookie jar is maintained by your browser. What does that mean? That means if I have a computer and I have 3 browsers on it, if I have Safari, Chrome, and Firefox, the cookies that get set when I'm using Safari are not transferred over when I use Firefox, or not transferred to Chrome. Okay, and if I have multiple devices, the same probably is true. It's the same in the sense that, like, if I'm using Safari on my computer, I'm using Safari on my phone. Those are different browsers. They're different software implementations of the same software, and so the cookie that gets set on one won't get set on the other. Now, there's a big exception to this. The exception is that if you're using a browser that's provided by a company, say it's Firefox, say it's Google, say it's Safari, Apple, and they know for usability reasons that if you set a cookie on one instance of a browser, say I'm logged into Apple and I set it on my computer, Apple may take the prerogative to synchronize those cookies to my iPhone, because my iPhone's also logged into my same Apple user account, and I'm also using Safari on my iPhone. So in that case, it will pass the information back and forth. Okay, so generally, cookies are scoped to a particular browser. So if you have multiple browsers, it's just for one browser. And if you have multiple devices with or without the same browser, it's also going to be scoped to that. But companies will try to synchronize your cookies just so that you don't have to always be logging in on every single device itself. Okay, so back to this. So once it recognizes that Alice is there, it doesn't really matter that she has more than one session ID. That's normal. Lots of people have different browsers or different computers and different devices and things like that. And so it's not going to freak out about that. It will just have 2 entries for her. And if Alice ever comes back with either of the 2 session IDs, then it will associate this as being Alice who's visiting the website. Again, another thing to say maybe here is because the cookie's associated with the browser, it's sort of obvious, but it's not associated with you as a person, right? It's not Alice herself. So if you share your browser with someone else, then if you log into one website and you don't explicitly log out, then what will happen is the next person will sit down at the computer and you'll still be logged in, right? That browser is still logged in. It doesn't have a notion of who the person is, okay? So sometimes you'll go to websites usually like government websites or things like that, and they might have an extra box when you're logging in that says, I'm using this from a public computer or something along those lines. And then what it's going to do is it's going to be a little more stricter about not honoring someone that comes back with the same cookie, particularly if the browser window closed, or maybe it will have an aggressive timeout. Like if there's inactivity for like as little as 2 minutes or something like that, then it might stop dishonoring on the cookie itself. Okay. Now, I can't remember if I have slides about this, but since I'm on to this topic, I'm going to explain it now, and then we'll just go through it a little faster later. Let's think about two different settings that you might see on a website when you visit it that have to do with cookies, whether you realize it or not. And then I also want to talk a little bit explicitly about like what does it mean to log out and that kind of thing when it concerns cookies itself. Okay. So the first thing that you might notice when you log into websites, there'll be a box that says keep me logged in. So keep me logged in means basically that the cookie is going to persist. Now, let's say you don't check that box. So I go to Gmail, it says, do you want to keep me to keep you logged in? I say, no, I don't. It's still not going to be the experience where I type in my password to get my inbox. I have to type my password in to get message 1. I have to type in my password to send a response to message 1. Like I have to type my password in for every action. Okay. So what it's doing is it's still setting a cookie. It's still recognizing me based on the cookie itself. The big difference is that when I close the browser, it's going to stop keeping me logged in. So something's going to happen to that cookie, and the event that triggers it is a browser close, and then I won't be logged in anymore. Okay. Now I want to I'm wording this very carefully because we have to think about what that event is. Okay. The other setting is some websites have a log out button, right? You press the log out button. And then when you log out, presumably the next time you go back to it, you have to put your username password in. So your session isn't working anymore. Okay. So what's happening when you log out or when you close your browser window without having made this setting? So what's happening there's two places this could happen. It could be that your cookie jar is actually deleting that cookie. Okay. If the cookie gets deleted from your cookie jar, then it will never get sent again. And then that's fine. You can see why that would log you out. The other thing it could do is it could be some setting that's happening at the server side. So maybe the server is deleting the cookie, or it could be more simply like just marking you as logged out. Like, oh, this is the cookie, but now that should be considered a logged out cookie itself. Okay, so when you set a cookie, the website could choose to have it delete itself when the browser window closes. So that's one possibility. So if you're relying on the browser window closing to delete a cookie, then that is a setting that the web server could use when they ask to set a cookie. They could give it an expiration that will close when the browser closes. Okay, but if you go to a website and you click the log out button. Okay, it's the cookie was already set. It was set when you logged in, right? So now maybe the website will try to like reset that cookie or change the settings of the cookie. But generally what happens is when you log out is the cookie doesn't disappear. Okay, so the cookie is still there. You keep sending it to the website. The website still knows it's you, but what the website will do is they'll just mark it as being logged out. Okay, so the website will just say this cookie, the user requested that they be logged out. So I'm no longer going to if I see this cookie come back, I know it's Alice that's coming back, but at the same time, I'm going to ask for her username and password. Okay, so again, it's a website policy that's being set. It's not something usually implicit with the cookies themselves. It's usually nothing that's getting changed on the user side. Okay, so the user is still sending the cookie. So again, with another example would be, I'm doing my Gmail on a computer that I share with other people. Say I click the sign out button. Someone else sits down at my computer. They type in Gmail, right? What will happen is my cookie will still be there and it will still get sent along. What changed when I click the logout button is that Google's saying, okay, I'm no longer honoring this cookie. Okay, I still have it. I still know who it was that was logged in the last time. But because they asked to be logged out, I'm going to make them submit a username password. And then who knows, maybe it will be a different person that submits it the next time. Okay. So anyway, so that's just some details on how you kind of get rid of cookies. Another thing is a user can delete a cookie at any time. So anytime you want, you can go into the cookie jar, you can clear it out, you can delete it. Another option that you have is private browsing mode. So there's some confusion about like what is private browsing mode? What does it do? Is it like Tor? Does it hide your IP address? Like what exactly is different about? I know it doesn't keep a history, so that's like the sort of selling feature of private browsing mode. But aside from not keeping a history, what it does is it actually deletes your cookie jar for that session, for that private browser window, but it doesn't touch your cookie jar for your normal browser session. So sometimes if you're having trouble like logging into a website, or you're in some sort of loop where it tries to log you in and it's looping or something, or there's all sorts of weird like kind of technical things, a good debug thing to test is open up private browsing mode, go to the website in private browsing mode, and what it does is it basically it's like you just bought a brand new computer and you never turned it on or you're turning it on for the first time, never been connected to the internet. It has no cookies. It hasn't picked up anything from any other website. And it's like a freshly installed browser when you go to it. Okay. But it's different than going and deleting your cookies, because once you delete your cookies, then like every website that you've logged into, you now have to log into again and things like that. Okay. So anyways, that's what private browsing mode does. Okay, users, you have your cookie jar is your own. Okay, so you can do different things to control what cookies get set. You might configure it so that you never accept any cookies. You can just turn cookies off. If you do that, you'll struggle being able to access almost any website that requires some sort of login or something like that. You can disable third-party cookies. So these are cookies from third parties. We'll kind of go through what that means in a couple slides. And you can clear your cookies at any time, and then the browser will empty your cookie jar. You can also set your browser so that every time you close the browser window, it clears the cookie jar. So that's another setting that you could use. Or you can manually go in at any time and clear out your cookies. And then private browsing mode is kind of like a temporary clear. So it clears it for, as long as you're in the private browsing mode window, you get a fresh cookie jar with no cookies in it. Now, as you use private browsing mode, like say I open private browsing mode, the first thing I do is I go to Google. When I first go to Google, that first request has no cookies because I have nothing in my cookie jar. But then Google right away is going to want to set cookies, and private browsing mode will accept them. So it will accept cookies. It's not like a mode where cookies are disabled. It's just a mode where you start with no cookies. So you start from scratch. You start with a fresh cookie jar. And then as you use private browsing mode, it will pick up cookies. And then when you close private browsing mode, because it's not your real browser, it's this temporary browser, then it will clear the cookie jar again. And then next time you open private browsing mode, you'll again have a clear cookie jar. Cookies will eventually expire. The server has control over that. If they want to make your cookies expire in 40 years, they can do that. So you can't really rely from a user trying to control their cookies. You can't really rely on expirations to do anything meaningful. And then for assignment 2 in this course, you did a usability study where you looked at some extensions that would help you manage cookies and see cookies, and maybe do like a site-by-site sort of thing, like I'll accept cookies from this site but not from this other site. Or in terms of the cookies themselves, I'll accept any, if Google wants to set a cookie on a website that's not Google, that's fine, but I don't want Facebook to do the same thing, or whatever the example is. And then the server, as I said, it controls its cookies. And so whether it clears your cookies or not, like say you tell it to log out, you have no control. You can't see what it's doing on the server side. So you have no ability to know what the server's doing. Okay. And then the two examples being the keep me logged in and the logging out, explicitly logging out. Okay, what do cookies look like? So let's say we go to a website. This is an example of TSN. We can actually do this. Okay, I don't know why that took so long to load. But anyways, here I am. I'm on TSN. We'll use our friend that we've seen from previous lectures, inspect element. So this shows me lots of different information about the website itself. I have everything that was loaded on the website. We'll be looking at some of these other tabs next class. And then if I go into, let me see if I can find it. Storage. So if I go to the storage tab, this is basically everything that this website wanted to store on my computer. And so cookies is one of the categories. Okay, so you can see I have a bunch of things that want to set cookies. You can see for tsn.ca, there are a bunch of cookies that are set. I'm just noting that I'm not signed in, so I hopefully won't get session hijacked by putting this video on YouTube. Yeah, you can see that there were a bunch of websites that wanted to set cookies. That's why they're in this list. But for whatever reason, my computer didn't accept it. Okay, so it didn't accept to store these cookies. And the main difference, what's the difference between TSN and these other things is, well, I'm on the website TSN, up here, sorry. I'm on the website TSN, and the cookies are being set by TSN. There's a match there. But that's not true of any of these other things. Okay, so these are what we call third-party cookies, which I noted before. Now, what's happening here is my browser is when you get a browser for the first time. Now it was different 10 years ago or 20 years ago, but now when you get a browser, it's going to have some settings that make it harder for you to be tracked by cookies. Okay. So what I can do is I can go in here, for example, I can unclick prevent cross-site tracking. Now when I load the website, it's going to be a little bit different. So you can see some of these third-party websites were able to set cookies. And you might also notice that a lot more, it's sort of like when the website woke up and realized that, oh, I'm not blocking third-party tracking, then there was a whole bunch of extra third-party tracking cookies that were added. Okay, so let me first re-enable that setting, and then we'll go back to the slides. It sort of shows the same example. Okay, so we have a bunch of cookies for tsn.ca, and then we have a bunch of domains that when I load TSN, these are domains that are also getting loaded at the same time. And the name of the cookie is being chosen by tsn.ca. So if they call it permutive ID, that's the name that they chose. That's fine. They also choose the value to put into it. Sometimes the value just looks like a random string of numbers. So for things like user IDs and things like that, that's what you might see. Sometimes they're numbers, so you can see this is a number 1. There's 1.1. It kind of looks like some sort of addressing system. Sometimes it's more like code, so you can see here there's this success true, so this is like a JSON string. This says the word true, so like a human can look at that and read it. This is kind of like URL parameters that are being set. So what the value is, it may be some machine readable thing. It might be a human readable thing. It really depends on who's programming and what the purpose of it is. Another thing you might notice is that there's tons of cookies. So I sort of gave the impression that you go to a website, it sets a session ID, and then that's sort of it. But in reality, websites set all sorts of cookies for all sorts of things. Cookies don't just govern logins. So logins are one component, but everything about the website gets governed. Like, for example, if you choose to go to a website, it displays it in French because we're in Quebec by default, but you're able to trigger it to display in English. The website may be programmed to set a cookie to remember that you switched to English. Then if you close your browser, you come back tomorrow and you go to the same website, it will show you the English version now because it remembered that you want to have access to the English version. Okay, you might zoom in, you might zoom out, you might put on like dark mode or night mode for the website. lots of different things that you might do with the website itself. All these things can be stored in cookies, and then when you go back to the website, you get the same sort of experience as when you left the website for the last time. Okay. The next field, so you have the name field, which is set by the server. You have the actual value, which is set by the server. So we're sort of moving through this diagram from left to right. The next thing is the domain. What this says is when the cookie should be sent back. And what your browser is going to do is it's going to remember that this cookie was set when you went to tsn.ca. And so it's going to do a comparison between these two. And it's going to decide whether it can return the cookie to you. And we're going to have some slides that show like what's the .tsn.ca mean as opposed to, say, just tsn.ca and things like that. Actually, okay, maybe it's here. But so tsn.ca, what that means is it will send it to either an exact match. So if you are exactly visiting the domain tsn.ca/whatever, then it will send it. But if you're visiting, say, a subdomain like images.tsn.ca, then it will also send it as well. So you can think of the dot here as an asterisk or a wildcard. So it basically is like either the exact domain or any kind of like subdomain of it. Okay. This doesn't have a dot, so it says www.tsn.ca. So it will only go to www.tsn.ca. It won't go to any subdomain of that, not that there would be one. And it won't go to any superdomain either. So if it was images.tsn.ca, it wouldn't go to that. If I want to share the cookie between www.tsn.ca and between images.tsn.ca, then this is how I would denote it. Okay. And you can't like limit it. You can't say, okay, here's 3 subdomains and I want to share it with those, but not with any of the others. It's sort of all or nothing. You sort of take it. Okay. The next thing is this is probably a mistake. Okay. So what this says is it will match either exactly to www.tsn.ca or it will match to the subdomain of www, but you generally don't have subdomains of www. So that looks like a mistake, but that's what it means. It means it would match to exactly this or any subdomain of this particular string. Okay, the next thing is a path restriction. So you can also say only send it back if it's tsn.ca/images/whatever. Basically, nobody ever uses this, so you as far as this course is concerned, you can more or less ignore it. But it is there. You could restrict a cookie to not just a particular domain, but a particular path as well. Then you have your expiration. So how long is this cookie going to be kept around for? The expiration is either a date, usually with a time. It wasn't I didn't pull it open far enough for you to see it. And then you also have the word session. What that means is until the browser window closes. So once the browser window closes, then it will get sent. Okay. Next thing is the size of the cookie. The size is basically just a function of how much data you're putting into value here and how long the name is. Okay. Everything else is constant size. So, for example, here you can see _GAT, so that's only 4 characters. The value that's being stored is only the number 1. Okay, so that's a really small cookie, and you can see, yeah, it's only 5 bytes long. And then some of the other ones, this one I was looking at, it looks short, but actually the name is really long, and it's the value that's short. And so that one ends up being 42 bytes. This one has a really long name, it has really long data, it has 290 bytes. So anyways, the function of how big it is basically just what you're seeing on the screen. Okay, then you have some security flags. So the security flags are secure and HTTP only. We'll talk about those. I think there's a slide. Actually, okay, we'll talk about them now. Okay, what does secure mean? So what secure means is I'm going to set a cookie, and presumably when I set the cookie, you're visiting my website over HTTPS. If you ever come back to my website, I only want you to send this if it's over an HTTPS connection. Okay, so if you're going to tsn.ca and it's over HTTP as opposed to HTTPS, your browser will still send all the cookies where this check isn't marked. Okay, so all those cookies will still get sent, but the ones that are marked, it will not send. Okay, it will say it just won't send them. That's it. No error message, nothing like that. It just won't send them along. Okay, so if, for example, you have a session ID, so a cookie, and the value of the cookie is basically like a login credential for this website for a user, then what you want to do is you want to make sure that that's marked secure. Some websites you go, they mark everything secure because the whole website is always served over HTTPS. So that's kind of like the best thing that you would want to see. And then for websites like this, there's still a mix of secure and unsecure cookies. Okay, the next thing is HTTP only. Now, if you look at that, it kind of looks at like HTTP as opposed to HTTPS. So you might think it's kind of the opposite of this cookie or something like that. But it actually has nothing to do with the distinction between HTTP and HTTPS. The distinction here is there's basically two main ways that a user would go to a website and submit a request. Basically go to a website and say, give me, like, say, the HTML file that's here, or give me this image, or give me this JavaScript. Okay. The first reason is that the user somehow navigated to a website. Maybe they typed in www.google.com, they clicked on it, they opened a bookmark, something like that. But basically the user browser initiated this request. The second way is they downloaded some JavaScript, and the JavaScript started running. And when the JavaScript started running, it decided that it wants to go visit this website or pull this data or fetch this image or whatever it is. Okay. Now, when JavaScript initiates a request for information, it uses this protocol called XML HTTP request. Okay. It looks different. So your browser, when it sees, like, you go to a website and all of a sudden you have to load 10 different images or 100 different images from all sorts of different servers. When your browser has that sort of bird-eye picture, it knows which of those were created by, like, the HTML of the website itself and which of those are being requested because some JavaScript is running. Okay, and it can distinguish between the two of them. Now, because JavaScript can just load any resource that it wants to, sometimes people worry about what happens if you get bad JavaScript running. Next class, we'll talk about cross-site scripting, which is essentially that attack. And so as far as cookies are concerned, what you could do is you could set your cookie so that if JavaScript ever comes back to TSN, you don't send those cookies along. So those cookies don't go along. Now, I will note here, you might be concerned, well, like, does the JavaScript see it? Like, somehow I get JavaScript running on your website and I as the JavaScript go and ask for google.com, and a bunch of cookies associated with Google get thrown into that request. Does the JavaScript see those cookies? And the answer is no. Okay, so all it does is it creates a request, but what happens is that those cookies will go along for the ride. We're going to see why that's a problem in a little later in the lecture with something called cross-site request forgeries. But anyways, for now, HTTP only is another flag that you could set, so that any requests originating from JavaScript wouldn't be run. Okay, then I showed you this already, but your browser will probably have some settings to try and limit cookies. And so if you unclick that, and you reload the website, you'll see that all of these cross-site URLs are also being able to set cookies, and you might also see that there's more, sort of resources that get loaded here that want to set cookies as well. Okay, now I want to go back to all the way back to here. So we talked about what does it mean to match. Like, does this match TSN and things like that? So I want to revisit that with a little bit more detail and give you a concrete example of what matching means. Okay, so let's say that I'm going to a website. The website is encs.concordia.ca. Okay, and encs.concordia.ca is setting the cookie. Okay. And when they set the cookie, they're able to decide what domain should match this website when someone comes back to this website, should the cookie be sent? Yes or no? Okay. And so there's going to be some rules. This is where the policy itself actually kicks in. It also has to do with something called origins. And origins are important for this lecture and also for next lecture. So the origin for the cookie itself, the website that set the cookie, is encs.concordia.ca. It's putting a rule in for, if I go to other kinds of domains, should the cookie be sent or not? And essentially what the policy would be is if the origin is the same, then send the cookie. And if the origin is different, don't send the cookie. Okay? So this is sometimes called same origin. And it's sort of the same rule that's in the same origin policy that we'll talk about next class. Okay? Same idea. The same origin policy it is about JavaScript, not cookies, but it was created looking at the cookie policy and trying to match the cookie policy itself. Okay, so if encs.concordia.ca sets a cookie and they say, I only want it to be sent back if the user is visiting exactly the same domain that I am, then that's fine. The browser's like, that's great. That's the normal scenario that we're expecting. Okay, it's an exact match. Okay. So sorry. There's actually kind of like three things here. I should maybe have a diagram on the side that shows this a little better. So there's three like kind of origins that are being compared. So there's the website that you were visiting when the cookie was set. So that was, say, encs.concordia.ca. There's what's in the cookie itself. So what's in the cookie itself is, say, encs.concordia.ca. And then there's what website am I visiting the second time? So the first time I was on this website, it set a cookie, and this was the domain that's in the cookie. Now I'm going back to this domain. Is this cookie being sent? Yes or no? And so the answer is yes, it is being sent because all three of them agree with each other. Okay. Let's say I go to images.concordia.ca, concordia.ca, or say canada.ca. In all three of those cases, this cookie is not going to get sent because none of these domains match the domain that was set. Okay, so I set exactly encs.concordia.ca. These are not exactly that. And so this cookie does not get sent by my browser when I visit any of these three domains. Now, what I can do instead is, am I allowed to ask for it to set encs.concordia.ca plus any subdomain of it? And the answer is yes. The browser says that's fine. If you're encs.concordia.ca, you're setting a cookie, you are allowed to set yourself, not just that it gets returned for your exact domain, but any subdomain as well. So in this case, if a user is going to exactly encs.concordia.ca, it will get sent. If they're going to say images.encs.concordia.ca, it will get sent. If they're going to just concordia.ca, it will not get sent, okay, because it doesn't match this pattern. Okay, this pattern says encs.concordia.ca or any subdomain of it. Concordia.ca is a super domain of it, okay? It does not match images.concordia.ca. Okay, it has to start with encs.concordia.ca. Then there can be anything in front of it. So it could be nothing in front of it, or it could be images.encs, but it can't be a sibling domain. Okay, and if it's a completely different domain, it's not going to match either. Now, maybe I want to set those kinds of things. Okay, so maybe I do want my cookie that I'm setting here to be shared with concordia.ca and images.concordia.ca. That's a very natural thing. So what do? So the answer is, well, I can set it to be a super domain of myself. So encs.concordia.ca can set its cookies so they don't just get responded to itself or sort of subdomains, but it can go up a domain as well. So I can say, I want my cookie to be sent back to anything.concordia.ca or concordia.ca itself, okay? And the browser will accept that. So the browser says that's a valid thing that you're allowed to do, okay? So in this case, encs.concordia.ca images.concordia.ca, just concordia.ca, any superdomain, well, any subdomain of concordia.ca, superdomain of encs.concordia.ca, this cookie is going to get sent. The only kind of website it wouldn't get sent to would be like a completely different domain, like say canada.ca. Okay. Now, what if I wanted to share my cookies with canada.ca? Can I go up another level and just do, say, a .ca? And this is where the browser will say, no, that's too far. You can't go all the way up. If you go all the way up to .ca, then, or say it was .com, which is a much more popular domain, the cookie one website sends, it's going to get sent to like every other website, well, every other .com website on the internet, and it's just completely unscalable. Okay, so browsers will not let you set something at the top level domain. Okay, you're allowed to go up to a domain, but not all the way up to a top level domain. Now, what if you're concordia.ca and you want to set a cookie for canada.ca? Okay. This is what we call a third-party cookie. It's basically you're visiting one website and it's trying to set a cookie for a completely different website. By default, this is going to nowadays it's going to be disallowed, but there are ways that you can probably turn this off. And it used to be the case that you were allowed to do this. The reason it's not allowed is usually a privacy reason. So we're going to go through the privacy example in a bit, but it allows too much. It makes tracing people across websites too easy. Now, let's say that we set a domain, and I mentioned there's this path field. No one ever uses it, but it is there. So let's just consider one example. So what I could do is I could set the same domain and I could set the same path. Then what that means is, what that means is if I visit this website / this, it's fine. Any sub path along this is fine too. But if I go to a different website, for example, Manon's website, then it's not going to work. Okay, so this is hopefully a review, but I'll just keep going over it just to make sure that we're getting what happens. So normally when I go to a website, the website usually has a bunch of like ad libraries and a bunch of weird stuff like that. And so what it will do is it will say, I want you to go and request JavaScript or other like images and things like that, other resources from a bunch of other domains. So say from Google, Snapchat, DoubleClick, Twitter, that kind of thing. So what happens is I create all these outbound requests, what my browser does, okay? And the browser intercepts it, and it says, okay, I'm going to check all of these against my cookie jar, okay? Now, because this request is going to google.com, it doesn't matter that TSN is the website that's being visited, okay? What I'm looking for in my cookie jar is, are there any cookies that were set when I was visiting google.com previously? They're set up in such a way that google.com is a match for the website I'm now visiting, which is google.com. If that's the case, then I'm going to throw the cookie in. So if there's cookies for Google, it gets thrown into this request. Say I don't have cookies for these two websites, they don't get thrown in. There is a cookie for Twitter, so x.com now, I guess. So it gets thrown in as well. Okay, so what the browser's doing is they're checking where you're going. They're checking against the cookie and what's set in the cookie itself. And then they're doing some other checks like, is it expired? If it's expired, then it will delete it. And we mentioned those flags. So depending on whether this is over HTTPS or whether it's JavaScript that's initiating these requests, it may or may not send them as well. Okay, so your cookie policy is basically like going through this checklist of should I put the cookie in, yes or no, for all of them itself. Okay, now notice that this request, because it's going to google.com, even though TSN told me to load this resource from google.com, I am requesting the resource from google.com. So the cookie that's getting sent is google.com's cookie. TSN does not see this. TSN is not on the wire. So TSN, it made me request something from google.com, My browser said, wait a minute, you're about to go to google.com. I'm throwing Google's cookie in with it. But the only person that sees that cookie is Google. Okay, so it's not seen by any other kind of cookie itself. Okay, so this is what we call a cross-site cookie. Okay, because the site that you're loading is making you create a request to another site, and your browser's throwing the cookie into this other site. So by going to tsn.ca, my Google cookie is being sent to google.com. That's a cross-site issue. Not an issue, but like a feature. Okay, that's to distinguish it from, say, a third-party cookie. So a third-party cookie is TSN trying to choose the cookie that gets sent to google.com. The cookie here that's being sent to google.com is a cookie that I happen to have on my computer because I've previously gone to google.com. It's not a cookie that TSN set. So TSN is making me send that cookie to google.com, but it didn't control setting that cookie. Okay, it kind of forces me to send that cookie, but it didn't force me to create that cookie or choose what the value is in that cookie or anything like that. Okay, so cross-site cookies and third-party cookies are different. They both involve, two different, like, cookies spanning two different domains, but they're different in terms of who set the cookie essentially. Okay, there's this little video. Because I'm recording this lecture, the sound's not going to go through. It's not going to play right. So what I'm going to do instead is you're watching this on a playlist on YouTube anyway, so I'll just throw this video into the playlist. If you want to watch it, you can. It's basically just a fun video that tries to explain cookies. It's only 2 minutes long. It's animated and things like that. But technically speaking, we've seen everything that's in the video itself. Okay, now that we've seen sort of the mechanics of cookies, and hopefully we're pretty comfortable with how cookies work, let's think about some of the ways that cookies go wrong. So what are some of the issues that we have with cookies? So the first thing we'll consider is third-party tracking. So let's just do this as an example. Let's say that I go to a website like Lululemon, and so I send a request for it. It sends it back the index. And let's say I'm looking at a particular shirt. So this is the shirt I'm looking at. I'm thinking of buying it. What will happen, what's possible that might happen, is that Lululemon, they want to advertise their products to me. Okay? So what they might do is they might subscribe to a third-party ad agency. And what the ad agency is going to do is it's going to sort of track all the people that visit the website and the things that they look at, and it's going to try and help the website in some sense in order to market to the people themselves. Okay, so this is what it may or may not look like. There may be an ad agency, let's call it Agile 1. It's here, and what will happen is that the user will send a request. Because I downloaded index.html, inside of it will make me load a request to agile.com. And what Lululemon will do is, because they're working with the third-party ad agency, is they'll also send along the item that I'm looking at. So say every item has a unique identifier. I'm looking at 9483. So that's the number that I'm looking at. Okay. So now Agile 1 knows that it doesn't know who I am. Say I'm not logged in or anything like that. But what it does know is that some user was coming here and that user was looking at this particular item. Now, if Agile 1 wants to track me, what they can do is they can give me a unique identifier. Okay, so they'll set a cookie. It will have a unique identifier. Usually the reason I'm requesting something from them is, I'm maybe downloading some JavaScript or something like that, maybe an image, I don't know. But this could just be a trivial thing where it doesn't actually need to send anything back other than the set cookie request. But anyways, it's going to set a cookie 55, and it's going to have a backend database, and it's going to say the user that has session ID 55, they're interested in this shirt 9483. Then later I'll go say to CBC. Okay, now CBC, they're kind of government funded, but they also need to have revenue, and one way that they make revenue is showing ads. And it may be the case that if a user goes to CBC, they see an ad, they click on it, that somehow CBC get more money than if they just showed the ad and the user didn't click on it. So it's sort of in their interest to try and show interesting ads to users and things that users might want to click on. Okay, so CBC may say, hey, we're going to work with ad agencies as well. So Agile One or whoever it is, we work with those people as well. So what will happen is I go to cbc.ca and CBC says, okay, go load an advertisement from Agile One. Okay, the same web server that was here. So what happens? Well, my browser sees I'm about to request something from Agile One. Do I have anything in my cookie jar that matches this? The answer is yes, I have this cookie that was set previously. It's in my cookie jar. Okay, so as I'm about to go to Agile One, it throws this cookie in and it sends this request. So from Agile One's perspective, it says, I just got a request for an ad. So I have to cough up some ad. I have lots of ads I can choose from. There's lots of companies that advertise with me. So I'm going to choose an ad that I want. But I'm noticing that I think I maybe have seen this user before because I've set a cookie for them. So they'll go in their backend database and they'll say, where have I seen user 55? And they'll be like, oh yeah, I remember. User 55 was interested in item 9483 from lululemon.com, right? So what advertisement are they going to show you? They're going to show you exactly, for example, an advertisement for the exact shirt that you were looking for. Okay, so you may have experienced this browsing the web where you're looking at some sort of product, maybe you're researching something, maybe you're looking at cars or something like that, and then you go to like news websites or third parties like that, and for some reason it's showing you like the exact same ads. It's showing you ads for the exact same things that you were looking at, right? And so this is what's happening behind the scenes. It's all enabled by cookies. It's also enabled, though, by having common parties that are sort of ad agencies that are behind all these websites. Okay, so if CBC works with a different advertisement agency than Lululemon, then this cross-site tracking doesn't happen. Okay, you can't. And this is what it's called, by the way, cross-site tracking, because somehow what I was doing on Lululemon is somehow being tracked across when I go to cbc.ca. Okay. Now there are like ads, or there are companies that are on almost every website. So Google is on almost every website. Google doesn't necessarily use it for advertising. That's one of the features of it. Another feature is that it can cross over, like it can try and figure out, like the reason you would put it on your own personal website would be you want to get some insight into how people are finding your website. Like what website were they on right before they clicked on yours, right? And so if everybody enables Google, then Google can set a cookie and they can track users around, and then they can give you lots of information about who your users are and the other kinds of websites they visit and things like that. Okay, so as mentioned, we call this a cross-site request. So cross-site request is when I go to one website and it makes me load a resource from a different website, and then my cookie goes along for the ride. Okay. Now, cross-site requests, you might, if you've heard of an attack called cross-site request forgery, which we'll talk about in the next slide, you might think this sounds bad. Cross-site request sounds like a bad thing, okay? But cross-site requests are not bad in and of themselves. They're actually a good thing, okay? What they do is they enable things like, for example, there's Facebook. I'm sure you're familiar with it, although it's not as popular today. It's a social media platform. They have the ability for you to share news articles that you've read and that you've liked, okay? And the way you might do this is you might set the website. The experience that you might have is you go to CBC, you read the article, and it's not like you have to copy and paste the article because you liked it into Facebook. There's a button right on the CBC article itself, okay? And it's like a thumbs up button, and if you click it, it will automatically like it on your Facebook account. And depending on how it's configured, it may do things like repost the article or create a post about the article itself. Okay. Another thing you may or may not see is when you're looking, even though you're on the CBC website, beside the like button, it might say 3 of your friends have liked this article. Now, sometimes websites do this for sketchy reasons, like it's just completely made up for engagement. But in this case, with Facebook, it's reputable. And like it's literally, it knows which friends of yours. It might even show you like the pictures, like the little icons for the exact friends that like this article as well. Okay. How does that all work? Is it that CBC is somehow asking Facebook, Facebook's telling CBC about your friends, and then CBC is displaying the information to you? If that's how it worked, that would be a violation of privacy, right? So the reason it works is because of cookies and cross-site requests. So what happens is CBC creates like a little box, like an empty box, call it an iframe, that's on the website, and it says Facebook's allowed to fill this box in any way they want. And so your browser goes over to Facebook. It says, give me some JavaScript. CBC says the name of the JavaScript itself. Facebook says, okay, I see that you want me to give you the JavaScript for this like button, but I also see that you're logged into Facebook, okay? Or a cookie's coming along with you. Because this cookie's coming along, we're not allowing third-party cookies, right? So CBC didn't create this cookie. Because there's a cookie here on this request, the only possible way that this cookie could be there is because this user had gone to facebook.com with their browser sometime before this request is created, okay? So they already had a cookie in their cookie jar. Probably they have a cookie in their cookie jar because they're logged into the website. So let's assume that's the case. If they're not logged in, then Facebook will just show a generic like button. If you click it, it will say, okay, log in, that kind of thing. But assuming the user's already logged in, Facebook will recognize that they're logged in because they see the session ID, and they'll go look it up in their database, and they'll see, oh, I know this session ID, it's a valid one. I haven't canceled it or logged this user out yet, and I know exactly who the user is. I know it's Alice. So then what Facebook will do is they'll send back a like button, but it's customized with Alice's information. So they'll look up her profile and see that 3 of her friends have liked it, and they'll mix all of that stuff in, okay? Now, Alice's browser is weaving this content together. So it got some content from CBC, it got content from Facebook. So when the browser looks at when the user looks at the website, they see some stuff that came from Facebook, they see some stuff that came from CBC. From the user's perspective, looking at the website, they don't know what came from CBC and what came from Facebook. It all gets weaved together, or it gets mashed up, was the term that we used to use. Okay, so it's weaved together. So I don't know what came from where, but the browser knows. Okay, so the browser knows, and because it's all getting weaved together in the browser, CBC doesn't see anything about your Facebook, and Facebook doesn't see anything about CBC. So there's no information that's being shared between these two sites, unless if there's some attempt to try and either pass information back and forth. So we saw that actually in the previous example, where because Lululemon added this field to the link that went to Agile 1, Lululemon was sort of able to talk to Agile 1, so it was a way of passing information to it. So it could be that they are trying to pass information back and forth, or it could be an attack where like one of these two is an adversary. So maybe this is an adversary and they're trying to learn things about this website, or this website's an adversary trying to learn things about this. That we'll talk about next class. So those are variants of cross-site scripting that we'll look at. Okay, now another thing I want to talk about that doesn't have anything to do with cookies yet, but we'll need it later when we talk about an attack and how to fix the attack, is this is also something that has come up in previous lectures, but I'll spend a little more time on it. The way the internet works now is you go to URLs, they look like this. So take a second and look at this URL. So it's for google.com, search, so this is Google search. And you can see $query equals soccer and page equals 10. What this URL represents is it represents the 10th page of results for the query soccer. Okay? If I click on this, I guess I can't click on it. But if I were to click on this link, say I copy and pasted this into an email, right? And you clicked on the link, you would go directly to the 10th page for the query soccer on Google itself. Okay, so this is a little different than maybe how you imagine a search engine to work. So you might imagine that when I go to Google, it says, what do you want to search for? I type in the word soccer, I press enter. It shows me the first page of results, okay? And then if I click, give me the second page, right? How does it know that I'm the same person that wants that second page of results, right? So we know that we have cookies now. So you might say, okay, the first time I go, I set a cookie, and then the website remembers, it writes down that the user with this cookie, they search the term soccer, and they're on the first page of results. So then when I click the next button, then they see my cookie come in, they go look up where I'm at, like what I was searching for, what page I'm at, and they know, okay, the next set of results would be page 2 of the search query soccer. Okay, so that is how the internet used to work. So it used to work that way. The problem with the internet that works that way is that Google is storing a lot of information. So every user, they have to remember what was the last thing they searched and what was the last page they were working on. It's a lot of what we call state. Okay, so they're storing a lot of state about the user. What they'll do instead is they'll write basically what the user is doing into the URL, and then they'll change every URL on the page. So for example, if there's a next button on the page, it will just have the URL google.com search query soccer page 11 instead of page 10. And that's hardwired into the page now. So when the user clicks page 11, the request that they get is right in the URL itself. So whoever clicked on this, they were searching soccer, and now they want page 11. And what this does is it frees up Google from having to remember anything. Okay, so they don't remember anything. All they do is they rewrite all the URLs so that the commands are in the URL themselves. Then they just they receive a URL, they do what the URL tells them to do, and that's it. Okay, so we call this whole architecture RESTful. So let's see how it might work in an attack. So now we're ready to talk about the cross-site request forgery attack. Okay, so this is an attack because forgery is a spoofing attack. You can put it under S in Stride. And this is how it works. So we have Alice, we have an adversary, and this attack only works if the adversary can lure you to their website. Okay, so they set up a bad website, and somehow you get lured into visiting the website. Otherwise, it's not going to work. Okay. Now, how do they get you on their website? It could be phishing. It could be, there's a million different ways to get a user to go to your website. And generally speaking, the web is set up, like the security of the web model should be that even if you end up on a bad website that's controlled by an adversary, they shouldn't be able to do anything seriously or substantial to you. Okay. Other than what maybe they display on the content of the website itself. But in terms of your security, it shouldn't be like you get a virus by just visiting a website, or you get your credentials stolen or things like that. Okay. So it should be like relatively safe to just visit a website. It's not something you necessarily want to do, but it, the web is designed to secure you from this type of thing. Okay, so it's totally within the threat model that you might at some point end up on an adversary's website, and nothing bad should happen to you. Okay, but here's what happens is, so you download the HTML, and when you download the HTML can include links to anything. Okay, so any website, anywhere that they want. Okay, so it could include a link to bank.com, and the link could have a bunch of parameters that look like this. Transfer 100 from Alice to Eve. And because the bank doesn't want to, they don't want to remember that a user logged in, they looked at their checking account, and then they clicked their checking account, then they said, I want to create a transaction. And then they filled out the field, and then now they're about to send that transaction. The bank doesn't want to remember that full history of how the user got to where they are. So what the bank is doing, they're using this RESTful architecture. So they program URLs, and if they see a URL that says transfer 100 from Alice to Eve, then they're going to do what the URL tells them to do. Okay. So this is a problem because if the user has a cookie set, even though evil.com doesn't see the cookie, that cookie does get sent. Your browser says, oh, you're about to go over to bank.com. Let's look through your cookie jar. Oh, you have a session ID for bank.com, so I'm going to throw that in. And so this request that the bank sees, this first flow, it doesn't know that it was initiated by the adversary, as opposed to the user just using the bank app normally, because eventually they would get to the point where this is the kind of URL that would get created. Okay, so what the adversary can do is they can force the user to create this URL. The bank misinterprets it as something that the user was doing in the process of sending the transaction. Whatever the URL tells them to do, they'll do. So they might put this transfer through, send back a response confirming that the transfer went through. And now, just by visiting the adversary's website, Alice ended up transferring $100 from Alice to Eve. Okay, so this was a problem for the web that we kind of got rid of. I'm going to show you the trick for getting rid of it. But it was a problem, for a while. All right, so what's the trick for how do we prevent this, or how do we secure this from happening? Okay, so the trick is very, very simple, but it's a little hard to sort of understand. You have to kind of think about it for a while, I think, in order for it to sink in. Okay, what we're going to do is every time the bank doesn't want to go back to keeping state about everyone's, what buttons they were clicking on the website and how they got from website A to website B within the website itself. Okay, so they still want to use these RESTful architectures. And so what the bank's going to do is when they rewrite these URLs, they're going to throw in the user ID that's in the cookie itself. Okay, so the bank will say, every time you're actually doing something on the bank is creating URLs with instructions. It's almost like instructions for itself. If the user clicks this, do this action. If they click this, do this action. So they're putting all this stuff into the URL parameters. They always throw the cookie value of the user as well. Okay, and if they ever get a request that does not have the cookie value, then they ignore it. Okay, now they know the cookie value because they're the bank, so they can put this value here. And when they receive a request like this, the browser's putting the cookie here, right? And if the bank created this URL, the bank put the cookie at the end of the URL. Okay, because the two match each other, then we say it must have originated from the bank, right? The bank's the only one that could have put the value here. Okay, now in the cross-site request forgery case, could Eve put this cookie value here? She cannot. Why can't she put the cookie value here? Because she doesn't know it, right? She can force Alice to create a request that puts the cookie value in the request, but Alice's browser was the one that put the cookie here. Okay, Eve didn't see that. She doesn't see the cookie itself. Okay, so she can trigger Alice's browser into putting the cookie value into a request, but because the request is going to bank.com, that's the only criteria for the bank.com's cookie to be put here. By definition, Alice doesn't see it because it's going to bank.com instead. Okay, so she has no idea what the cookie is. And by the way, if she did know what the cookie was, she wouldn't have to do this attack in the first place. She could just session hijack Alice directly. Okay, so Alice can no longer forge this URL, even though this looks like a valid URL for bank.com, because it's missing this cookie element, which is the unforgeable bit. It's the bit that nobody knows except for the bank and Alice herself. It's a shared secret between the bank and Alice's browser. Those are the only two parties that know it, so no one can forge a URL for a website that they don't know. Okay, so that solves the cross-site request forgery problem. This, by the way, is probably the most complicated attack that you'll see and have to try and understand in this course. So if you're not getting it, just think about it a bit more. And of course, ask me questions about it. Okay, let's go through sort of the pros and cons of the policy that we've seen, the cookie policy. we'll do it for cookies themselves. Okay. So cookies are very useful, even though there are some attacks and there are some privacy problems with cookies. Cookies in general are a good thing. You want to not type your password in every time you go to a website, right? You want a website to remember that you want the English version instead of the French version. Cross-site requests, even though they sound bad, maybe if you're familiar with cross-site request forgery, they're actually a good thing, right? You want websites to be integrated into each other. You want, if you come to my website, I might embed a YouTube video, right? And so that's fine. You actually don't need cross-site requests to do that. But let's say you watch the YouTube video on my website and you like it, right? You should be able to do that from the website itself. You shouldn't have to click the like button on my video and then YouTube's like, oh, by the way, you have to log in, or we're going to move you over to youtube.com now. Like, it's just like you're watching the video, you like it, you press the like button. It likes it on your account, even though you're on my website, right? And the video keeps playing and there's no interruption to anything, right? So that's cross-site requests. So that's what they enable. Okay, so they're a good thing, a net positive for the web. But cookies have problems. So the first thing is if I steal your cookie, it's almost like stealing your password. I can hijack your session. It's not exactly the same because usually some deep administrative things you would have to retype the password in. So if I only am able to steal your session ID, then I won't be able to do some deep settings because it will ask me for the password. And I don't know your password. But and eventually the session ID will time out. And sometimes websites will set it up so that if, like, say I'm in Canada and they know that because of my IP address, and then all of a sudden I'm somewhere else in the world, they might say, you have the right session ID, you didn't ask to be logged out, but just to be cautious, we're going to make you log in again. So sometimes the website just chooses to force you to log in again. So stealing sessions isn't quite as strong as stealing a password, but it's very similar. You can do a lot of damage by stealing sessions. And the difference between stealing them or not is also is a lot of it falls on the website itself, how the website is programmed, which you as a user have no control over, right? So if the website is set up in a very secure kind of way where they're thinking about different attacks and adversaries, then they can really mitigate some of the damage from session hijacking. But there's other websites where as long as you're logged in and have the cookie, you can change any setting you want and they'll never log you out or they'll never require your password. And then the other con of cookies is that you can track users across sites as well. Okay, so that's what I wanted to say today about cookie policies. Next class, we'll look at a similar but sort of different set of issues concerning also cross-site kind of requests, but in this case, it will be cross-site uses of JavaScript. So the main instance would be you go to Concordia and there's a JavaScript running, but the JavaScript comes from Google. How does the browser figure out different security parameters around that particular thing? Okay, so we'll talk about that next class. So thank you, and I'll see you all next week.